Hello guys, I'm back with another concept of geometrical optics, and this time this is a nice concept which would help you in preparation of IIT JEE Advance. And in this concept I would demonstrate you that how can you write the laws of reflection in vector form. So you can see that there is a plane mirror, this one, and there is a normal to the mirror, this one. Normal is denoted by n cap. I am denoting the normal vector as unit vector n cap, and I am denoting the mirror as a tangential vector t cap. T cap denotes tangential vector, n cap denotes normal vector, unit vectors. And the incident ray, this is the incident ray which has a unit vector ei cap, and this is the reflected ray which has the unit vector er cap. R denotes reflected ray, I denotes incident ray. The angle of incidence and angle of reflection is equal, as you all know. Now I've already written the notations which I'm using, that ei cap is the unit vector along the incident ray, er cap is the unit vector along the reflected ray, n cap is the unit vector along the normal, t cap is the unit vector along the tangent. Hence we can write ei cap in vector form as, you can split ei cap into components. You already know that ei cap is a unit vector, hence its magnitude would be 1. So you can split ei cap into two components. The one component along n cap will be ei cap, which is 1 in magnitude, 1 cos theta, and another component along the t cap is 1 sin theta. So I have written ei cap as sin theta, 1 sin theta t cap minus cos theta, 1 cos theta n cap. Minus is due to the fact that n cap is pointing in upward direction, and the component of ei along n cap is pointing in downward direction. Okay, now I have written er cap. Er cap is the unit vector along the reflected ray. So it is equal to sin theta t cap and cos theta n cap. So now if we subtract these two, er cap minus ei cap, that is equal to 2 cos theta n cap, and this is our first equation. Now er cap is equal to 2 cos theta n cap plus ei cap, and if I calculate the value of ei cap dot n cap, then it is equal to minus cos theta. You can calculate this value ei cap dot n cap. So this would be equal to the n cap component of ei, that is minus cos theta. This is the third equation. Now if we put the value of cos theta from the third equation in equation 2 here, so we get er cap is equal to ei cap minus is due to the fact that this cos theta would be equal to minus shifts here and minus of ei cap dot n cap. So er cap is equal to ei cap minus 2 ei cap dot n cap into n cap. This is this dot product will give us scalar quantity, and this is represented with a unit vector. So this equation er cap is equal to ei cap minus 2 ei cap dot n cap into n cap. This equation is the vector form of laws of reflection. So I am demonstrating this by an examples. I am taking a simple example initially, and then I will take a tougher example. So in this example you can see I have denoted this capital I vector as an vector which is representing the incident ray. This vector represents the incident ray. Okay, and let me change a sign here. let us suppose that this is a negative component. This one. Okay, so this ray is going in downward direction, and there is a mirror which is placed in XZ plane. Why I am saying so? Because a mirror, plane mirror which is placed in XZ plane will have a normal which is equal to the normal in the direction of y-axis j cap. Okay, so this ray is going towards the negative y-axis obviously, so it will strike the plane mirror which is kept in xz plane. So we have to find out the unit vector along the reflected ray. So I am using a method 1, which is obviously the method in which I will use this formula which I have already created. So by the formula we know that ER vector is equal to ER cap is equal to EI cap minus 2 EI cap dot n cap into n cap. Now as I have changed the sign of j cap, I am changing this sign here also. This will be a negative sign. So now in this case, if I am multiplying this, then there will be a positive sign here and there will be a negative sign here, and 2 by root 3 j cap minus 1 by root 3 j cap is plus j by root 3. Okay, so I am repeating the thing that I have changed that sign here. So E r cap will be equal to, that is I cap minus j cap minus k cap upon root 3, because I have to take this unit vector, and the vector which is given in the above question is the incident ray vector. It is not a unit vector, so we have to convert that into a unit vector, and therefore we have to divide that vector with its magnitude, and the magnitude of this vector is root 3. So EI cap will be equal to I cap minus j cap minus k cap upon root 3. So now this negative sign is being converted into plus sign, because when I will calculate the dot product of n cap and EI cap, then n cap dot EI cap will be equal to minus 1 and minus 1 upon root 3. Why root 3? Because I have to evaluate the dot product of n cap with EI cap, with not E vector. So this is E vector, incident ray vector. So I have to calculate the dot product of n cap with EI cap. So EI cap will be obtained after dividing this vector by root 3. So here is the equation. You can calculate this equation by this formula. Now this is I by root 3. I am writing that I by root 3, and this is k by root 3 negative sign, and this is plus j by root 3, because 2 by root 3 minus 1 by root 3. So this is the unit vector, in fact, along the reflected ray. We have to find that unit vector. Now by trick I can say that if the normal is one dimensional, you can see that normal is one dimensional. This trick is applicable I would say that this trick is more suitable to apply when normal is one dimensional. So when normal is one dimensional, just change the component, just change the sign of the component of incident ray vector which is in the direction of normal to the mirror. I mean to say that you have to just change the sign of that component of incident ray vector which is in the direction of normal. So here normal is j cap, and you have to just change the sign of j cap in incident ray vector. So incident ray vector has a negative sign with j cap, hence we have to change the sign of incident ray vector to positive. So this will be a reflected ray vector. Okay, and if I wish to calculate its unit vector, I should divide that with its magnitude, and its magnitude is 1 by root 3. You can see that. So this is the method of writing the reflected ray vector. Okay guys, I hope this concept is understood by you. Keep watching for more videos. Thank you.